And we're live again. We will, let's see, actions. Okay, it looks like I just did one quiz for transformer connections. This is different. They updated something. I don't like it. Yeah, this is good. Alright. Again, if you're watching later, I am starting the streams earlier so that they can cycle through and come up correctly for everybody. And I will put up a picture of some sort that says I'm starting the quiz, starting going over things, uh, whenever that becomes relevant. Like whenever I start, so you can scroll through the playback bar and see when I start. Ooh. Hmm. Let me plug this in. Got one person watching. We'll give it another minute or so. I think I damaged the charger on my laptop just a little bit. Uh, I had my laptop sitting on a TV tray next to my desk, and I stood up the other day, and it knocked over the TV tray and the laptop, and everything fell on the floor. So, but I learned, and I have the laptop sitting on a TV tray next to my desk, which is the same. All right. We are about to go over the second lesson. Oh, there's a courseware for this one. So, not bad for doing that. Okay, let's get started. Uh, so, let's write it down. Control A, delete. All right. That will give us a pretty good indication when we started, if you are watching later. All right. A blank is an electric device that uses electromagnetism to change voltage from one level to another or to isolate one voltage from another. A transformer. Y'all nailed it. Good job. Page 13. Blank is the property of a device or circuit. Excuse me. That causes it to store energy in a magnetic field. That is inductance. I might have to go back over some of this because it is AC theory stuff, and I moved AC theory back after Transformers. But we will see. Alright. So inductance is what causes a magnetic field, or it causes it to store energy in the magnetic field. Blank is the ability of an inductor in a circuit to generate inductive reactance. Self-induction. So, whenever a conductor induces a voltage on all the conductors around it, it's also inducing a voltage on itself. And that causes it to do less. It's another form of resistance, really. Counter electromotive force is what we call that. Mutual induction. So, that happens all the time. There's always mutual induction happening. Usually it's negligible, so we ignore it. But if you read between neutral and ground with a voltmeter, you will see that there is actually a voltage going between the neutral wire and the ground wire. And we generally consider those to be zero. Like neutral is 0, ground is 0 volts. But actually, since the ground is wired to something that's bleeding off all of the current, or all of the voltage, the neutral will actually have a different amount of voltage than the ground wire. What is the turns ratio of a transformer with a primary current of 31 amps and a secondary full load current of 62 amps? 2 to 1. Yeah. So, the way ratios work is you set one side. You could say it's 31 to 62, but then you need to reduce that down as low as it will go, and it's 62 is is twice what 31 is, so it's a 2 to 1. I can see some of y'all don't bother with the math whenever I put it in a quiz. A transformer has a secondary voltage of 12 volts and a turns ratio of 10 to 1. What is the primary voltage? So, let's see. Secondary. Okay. So if the secondary is 12, that takes place of the 1. So this is saying for every 10 volts on the primary, you have 1 volt on the secondary. So you're multiplying whatever you have on the secondary by 10. So that gives us 120. It's a pretty simple math. I'm not going to show the work. 12 times 10, 120. A blank is an extra electrical connection on a transformer coil that allows a varying number of turns of a coil to be part of the circuit. Coil tap. So, let's see if I can find a picture. Aha, here's a good picture. Alright, so here's the picture. These are the coil taps right here. Those little bends. So basically they have the coil wound around, and then every once in a while they pinched and pulled out a spot for you to... No, I don't want you to send me notifications. Why would I want that? So you can move your connection to different spots to get slightly different voltages. Eddy current loss is power loss in a transformer due to currents induced in the metal field structure from the changing magnetic field. That's kind of hard for me to describe explain. This is the definition of eddy current loss. It's on page 20 of your rule of not your rule book of your Transformers book. Uh, let's see. Eddy currents are whenever the frequency of current is higher, the eddy currents from it changing back and forth uh, grow. There's more eddy current loss. It's related to skin effect, which is the higher your frequency. All this is frequency dependent. The higher your frequency, the more your current, the more your electrons are pushed towards the outside of the conductor. That's why we use stranded conductors a lot. Other than ease of pulling and ease of use, stranded conductors have a lot more surface area for skin effect. Uh, so the higher your frequency, the less of the conductor the electricity uses, actually. We don't get into that really. This would be if you were uh, like designing electronics and stuff. This is you would be worrying about skin effect and eddy current loss and what you are going to use as a conductor for different things. But we stick to 60 hertz, so everything's the same whenever you look at eddy current and things like that, because we have the same frequency for everything. We covered hysteresis already. Hey, somebody's doing the quiz right now. Transformer, its coefficient of coupling. This is one of those just mutual inductance, which we talked about earlier. Coefficient of coupling is another word for that thing. That's it. Liquid immersed transformers are typically immersed in oil. I believe it's mineral oil. Uh, Mineral oil is a non-conductive oil, so you're not going to want to immerse a transformer in like something conductive. But uh, the oil acts as uh, a coolant. If you know about heat rising, that's the same in liquids. So warm air rises, warm liquid rises. So as the transformer heats up the oil will rise to the top and cool itself off, and it will actually circulate itself. You don't need an actual pump or anything to circulate the oil. The temperature rise is the difference between a hotspot maximum core temperature and the temperature when not operating. That's, yeah, the hottest temperature that it has versus the lowest temperature is temperature rise. Yeah, that's electrical power circuits must be insulated by blank where they enter the transformer tank. Bushings. Yes, absolutely. Uh, you have to put bushings so things don't get uh, like the insulation doesn't get cut, and then it grounds out, and then things happen because uh, once the wires leaving the transformer are generally considered unfused because the transformer is considered the point of origination. Not, that sounds that's not the right words. It sounds like the right words, but it's not. Uh, The transformer is where the circuits are considered to start, uh, and so they are unfused unless you go back further. Like it's fused at some point between it and the generator, but you know, transformers are rated by their capacity in kilovolt amps. That is about so kilovolt amps, volt amps, and watts. Volt amps is a form of power. Kilovolt amps is just 1,000 volt amps. All right, let's launch the next quiz. Transformer connections, right there. Questions, answers. Show final score. 1 attempt. All right, new quiz is up. Good luck. Remember to go get your tests. Our next live stream will be at 1:45. Between here and there, you need to go to the school and get your tests. If you are more than 50 miles away, like if it's an hour drive, you can call the school and get them to mail the tests to you. You just won't have them today. It'll be a couple days, and you have to get them back to the school by the next class. I don't know what the rules are if you're mailing it, though. So, we'll see. Like, ask the school what the rules are for mailing, and they'll tell you. All right. You guys have a good lunch, and I will see you back here at 1:45.